This will be for the Khan Academy unit test, exponential models. Carbon-14 is an element which loses 10% of its mass every 871 years. The mass of a sample can be modeled by the function m, depending on its age t in years. The initial mass of the carbon-14 is 960 grams. Write a function that models the mass, the remaining t years since the initial measurement. All right, so this is an exponential equation. It's going to be in the form of y equals a times b to the power of x. All right, a is the initial value, and it says in the problem the initial mass is 960 grams. So a is going to be 960. Okay, and if you look at the write-up, it says it loses 10% every 871 years, and t is the variable for years. All right, in order to lose 10%, you start with 100%, and you remove 10%, and you are left with 90%. In decimal form, if you move the decimal over 2 places, that's going to be 0.90. Okay, you can write 0.9 if you want. But in order to lose 10%, you multiply by 0.90. So I'm going to take the initial value of 960 and multiply it by 0.9. Okay, and it says t is in years. So I want this to lose 10% over and over again. So I put t as the exponent on the 0.9. But as it is now, the 0.9 will be applied every year, okay, because it will be 960, and then next year it'll be times 0.9. The year after that, it'll be times 0.9. Okay, and so on. It's just going to keep going every time t increments by 1. But we don't want it to increment by 1. We want it to go every 871 years. So we want to divide t by 871. Okay, this way when it's 871, it'll be 871 divided by 871, that's 1. Then you add another 871, it's going to be 2 times 871 divided by that, and it'll be 2, and so on. So this is the final answer. So click in the box, type 960, and you can use the dot for multiplication. I like parentheses better. 0.9 inside parentheses, click outside, okay, and then hit the exponent button right here, and hit the fraction button to make the exponent a fraction. It's going to be t, down arrow, divided by 871. Okay, so that matches what I wrote. Ocean sunfish is well known for rapidly gaining weight on a diet based on jellyfish. Relationship between t and days. Relationship between the elapsed time t and days since the fish is born, m in milligrams modeled by the function. Complete the sentence about the weekly rate of change. Okay, they want to know each week the mass increases by a factor of. If you see factor of, that means multiple of. Okay, and round to 2 decimal places. So right here, this equation t, this equation is based on t, and t is in days. But they're trying to ask us what the weekly change is. All right, so we know that 7 days equals 1 week. Okay, and we want to know what this gets multiplied by each week rather than each day. All right, so we don't need the initial value. We just need to know what it's multiplied by each time. So we want to see what this is on a weekly basis. We cannot plug in 1 week for t because t is in days. Okay, so we need to plug in 7 in place of t because 7 days represents a week. So we are looking at 1.05 to the power of 7. And we're going to round to 2 decimals. Okay, I get 1.407 looking at the 3rd decimal. If it's more than 5, if it's 5 or more, you round it up. So this is going to be rounded off to 1.41. Okay, that is the factor or the multiple that occurs each time t goes up by a week. So the factor of that is 1.41. All right, the write-ups you can really just skim. Kyle sent the chain letter forward to the other friends. Elapsed time t is in hours. P is the number of people who received the email. All right, there it is right there. Complete the sentence about the hourly percent change. Okay, every hour there is a blank percent addition to or removal from. Okay, so your best bet here, if you want to see what it's increasing by each hour, we'll do it at t equals 0. We'll evaluate it. Okay, that's going to be 1.09 to the power of 6 times 0. So 6 times 0 plus 25.5. Okay, that whole thing is the exponent. That's going to be 1.09. 6 times 0 is 0. The exponent is 25.5. Okay, that's at hour 0. And then at hour 1, t equals 1, we got the 1.09. 6 times t is going to be 6 times 1 plus 25.5. Okay, we still have the 1.09. 6 times 1 is 6 plus 25.5 is going to be 31.5. Okay, now in order to see what it's multiplied by every hour, we'll just divide this by this. Okay, so we have 109 to the power of 31.5 divided by 109 to the power of 25.5. Okay, the base numbers match 109, so we keep that. And just subtract the exponents going down. 31.5 minus 25.5 is going to give us 6. Okay, calculator work right here, 1.09 to the 6th. And I get 1.677. Rounding to 2 decimals, you want to look at the 3rd one. If it's 5 or more, then this will get rounded up to 1.68. And that is what this, that's how the multiple, the factor that this increases by each time. Now, they wanted it in terms of percentage, okay? It said what percentage. So when you multiply by 1.68, that's 1.68 minus 1 or 100%, and that's going to be 0.68. Moving the decimal over 2 places, that's 68%. So multiplying by 1.68 will cause an increase of 68%. Okay, they said round to the nearest percent. So we got that, 68%. And that's an addition to. All right, after the Ice Age, the number of animal species changed rapidly. Time t in years. Total number of species, S. Okay, here we go. Calculate the following sentence about the yearly change. Every year, blank percent is added to or subtracted from. All right, so t is in years. Right, it said t is in years. And it's multiplied by 0.72t. So we don't have to do the thing with the 0 and the 1. Okay, this one's much more simple. T is in years. So each time t increments by 1, the value gets multiplied by 0.72. Okay, so this is less than 1. It's going to decrease each time t increments by 1. If you keep multiplying by the number less than 1, it's going to keep decreasing. So we have 1, which is 100%, minus 0.72, and that's going to be 0.28. Okay, moving the decimal over 2 places, that is 28%. So 28% is removed from 100% each year. All right, so that's all they asked there. Every year, 28% is subtracted from or removed. All right, first day of spring, entire field of trees blossoms. Relates elapsed time t in days. L is the number of locusts. Following sentence about the rate of change. The population of locusts gains 47% every blank days. Okay. This causes a gain of 47%. Okay, this is basically 147% minus 100%, so that's 47%. Right? We start with 1.47, subtracting 1, and that's 0.47, which equals 47%. Now, how often is that applied? Every time this whole fraction increments by 1, it's applied. Okay, so this fraction, this exponent, t over 4.8, just equals 1. Okay, as a result, t is just 4.8, because 4.8 over 4.8 is 1. Every time t goes up by 4.8, the overall fraction increases by 1, and it gets multiplied an additional time every time this whole exponent goes up by 1. So that's it. It's every 4.8 days. All right. Only thing you want to make sure of is that t was in days. Okay, and if you want to double check, t is in days. So it's just 4.8. All right, these write-ups are mostly unnecessary. Just skim it. T is in days. V is the number of views. Okay, complete the sentence about the weekly change. Round to 2 decimals. Every week, the number of views grows by a factor of. Factor of means multiple of, and we're looking at every week. Okay, now in this equation, t is in days. And like we said before, 1 week is 7 days. Okay, so we can't plug in 1 week here. We have to plug in 7 because the t is in days. This is basically the same as the other problem. We want to see what it's multiplied by each time. We don't need the initial value. We just want to see what this is going to be in 7 days. So we're just looking at 1.17 to the power of 7. Okay, and they said round to 2 decimals. All right, 3.001. Look at the third decimal. If it's less than 5, you round it down. So we're going to keep that at 3.00. That's what it's getting multiplied by every 7 days or every week. All right, so we're looking at 3.00. Factor of means multiple of. Let me see if it takes 3. It said round to 2 decimal places, but it's 3.00. Let's see. Okay, it took it. Good. All right, chain letter. T is in days. People who received the email is P. There's your equation. Following sentence about the daily rate of change. Every day, the number of people who receive grows or shrinks by a factor of. It means what you're multiplying by each time. Really, there's no work to do here because it says every day. and it said t is in days. Okay, so every time t increments by 1, every time it goes up by 1, this gets multiplied by 3, right? 4 times 3 to the first, times 3 to the second, times 3 to the third, and it just keeps going. It gets multiplied by 3 each time t goes up by 1. Easy one. So it grows by a factor of 3. All right, if the if the multiple were less than 1, then it would be shrinking or decreasing. All right, sunfish gain weight rapidly. T is in days, M is the mass, and they want to know, rounding to 2 decimals, the mass of the sunfish is increased by a factor of 9/7 every blank days. They're basically asking, because it's a factor of, it's a multiple of, they're asking how often it's going to be multiplied by 9/7. How often does the function get times multiplied by 9/7? How many days? Let's take a look. Now it said t is in days, so this part happens every day. Okay, but if you take 9/7 and square it, you're going to have 9 squared, which is 81, divided by 7 squared, which is 49. So this right here, if you ignore the initial value, this right here is the same as 9/7 squared. And this right here is raised to the power of t. So you can raise this whole thing to the power of t, but really when you have something with an exponent raised to another exponent, you just multiply the exponents. So we can just make it 2t, 9/7 to the 2t. Okay? So basically, we want to see how often this exponent goes up by 1, not this one. They asked us how often does it get multiplied or increased by the factor of 9/7. All right, so this has to go up by 1 each time, not this. All right, so just set the 2t equal to 1. And if you divide both sides by 2, we get t equals 1/2. Every time this goes up by 1/2, this whole exponent goes up by 1. So the 9/7 actually gets applied every half day. Okay, they said round to 2 decimals, but if you have an exact fraction, they usually take it. Okay, so-and-so is an ecologist. T is in years, number of tigers is N. Here's our function. Rate of change. Population loses 65% every blank years. Okay, it said T is in years. And in order to lose 65%, you start with 100% and you subtract or lose 65%. That's going to be 35%. Okay, converting to decimal, if you move the decimal place over 2, that's going to be 0.35. So multiplying by 0.35 actually removes 65%. Okay, and how often does this number get applied? Well, it's not every year because the years are divided by 2. So we want to know how often this increments by 1. Okay, so just set the t over 2 equal to 1, and then multiplying both sides by 2, solving for t, it cancels here, and t equals 2. Okay, so every time t increments by 2, the exponent increments by 1. This gets multiplied and it removes 65% each time. So it loses 65% every 2 years because the exponent is divided by 2. So that slows it down a little bit. Instead of every year, it's every 2 years.